Do you recognize the Twente additive manufacturing facility? They've got some traditionally poured concrete blocks over there, and that's actually an interesting way to recycle the extra material that you have at the beginning and end of your print while you're clearing the hose. Many companies just let this material go to waste, but Twente is conscientious, so they put the extra effort in to preserve this concrete rather than letting it go to waste. So, is this one full wall of the building?
Yeah, so this is what we're calling the south wall. It's the largest segment of each wall, that side and this side, a little bit smaller. This one's about one-third the size. And it's got the most graphic on it. The front side just has some trees. Ian, the boss, he's chosen to do a ram here, some other trees, something to just show some detail and what's possible with the design in the panels in each pattern. The coolest thing I like about it is if you like zoom in on each one, each panel when we print it, it doesn't seem like anything at all. They're just kind of like all these little like semicircles are what make the pattern. But panel to panel, you can't tell until, as I'm currently installing them on the building, they slowly make a full picture of a ram.
Try to get a quote from a contractor for a custom set of stairs. Custom stairs have to be generally hand built, but with 3D printing you can have as many steps as you want, whatever width you want, and whatever height you want, easily, and you can change quickly last minute. These are things that were not possible before. Custom concrete steps like this might cost $20,000 to $40,000, and when you consider how remote of a location we're in, it may be even more than that. Here you can see some concrete that they're using as a retaining wall for this dirt up here. It's another example of Twente recycling prints that didn't go exactly how they planned. This was going to be part of a skate park, but because it cracked, they didn't want to give it to the Rotary Foundation. Instead, it lives here holding up this dirt from this beautiful path that's currently a little bit flooded. That's probably why they're digging that pond over there. I'm sure it'll help with the flooding a little bit. Since it's such a remote area, Ian actually has to manage the wastewater and the freshwater facilities along with the electrical. An interesting fact is that in Canada, it's illegal to charge for water.
My name is Joost. I'm a student in mechanical engineering from Amsterdam. Got here to Canada to work on the ABB robots and make some products for during printing.
What do you got there?
We're working on a new application that we can use within the print, but the specifics are confident at this moment.
Dealing with clients that have to understand both metric and imperial across borders?
It's just really annoying. Finding the correct bolt within the ranges that is possible, having two systems working together. It's a headache at some point.
Even when you get to the cutting edge, you still have to remember the basics.
Yeah, you have to know your fractions.
Hey Jim.
Hey guys. Jared.
What's going on?
How you doing?
Good to see you.
Likewise.
What's our topic here?
My name's Raymond Arsenault, 23 years of industrial robotic automation, and I've been working for the past year with Twente Additive Manufacturing with helping them develop robotics. Right here we have our Leonardo setup, where we have our ABB robot attached to a gantry system, 9th axis unit, help them develop software for coordinated motion between the gantry and the robot.
The printer looks mostly the same, but there's definitely a lot of changes you've made in the past year and a half since I've been here last. So is there anything you can mention, things that you're happy to now have on the printer that you didn't have back then?
Well, I think it's the right way down now compared to when you were here before. I can't quite remember when you were last here.
September of 2021,
yeah,
2020.
So we're inverted now, which was our goal, our main mode of operation now. We've added some accessories to it in terms of allowing the cable track to go back and forth properly. We rotated the 9th axis to have our robot upside down.
Is there any way you can like clearly show or point to the 9th axis, or in a different angle I can go to demonstrate it more clearly?
Sure. Let's go over joint here. There's a pin here at the center of the beam, and that's where the whole beam rotates around.
So you can at any moment invert it or uninvert it?
Yes, and we can also use it on its side as well. That gives us a much further reach above and below.
Is there like cable management that happens between the inversion?
There is, yes. There's some cable management that has to happen.
Can you dig into any of that, or unplug everything, plug it back in?
No, it's not that involved in the setup. There is a flip that needs to happen to the cable track because of gravity. So we can go about 45 degrees before we need to do cable track modifications.
Would there be a circumstance where you would use that axis mid-print?
Not at the moment, no. We're able to get around all our printing challenges without having to utilize that.
We're on the site of Sakura Place. This is the World Housing Project where they're going to build 5 homes for single mothers. The idea is to create like a place for affordable living for women in transition. The land got cleared in the fall, and hopefully we should be printing pretty much as soon as the frost is gone, and have like 5 new families up here soon. So what's kind of cool about this project is, you know, we like doing hybrid. So the 3D printing is used when 3D printing makes sense, and we use timber when timber makes sense. And because this project is on a wooded lot, we're actually able to recuperate the trees for some of the furniture, some of the flooring, some of the other elements of the house that are going to really be gorgeous to mix the wood with the print concrete.
Local lumber flooring, that's a really high-end finish.
Yeah, well, we did it on the first house. I'm not sure if you saw in the Fibonacci house there, all that timber that came from this hillside as well. It's just part of building as ecologically and as economically as possible, is to use local sources when you can. Of course, we can't say that about the printing material at the moment, but the guys making the printing materials are getting closer, so that helps. So what makes this project unique is it's actually a continuation of the Fibonacci house. So the Fibonacci sequence is 1, 1, 2, 3, 5. So we're actually going to build 5 houses, and they're going to form the shape of a cherry blossom, and it's also going to be made up of 5 Fibonacci houses. The difference is there'll be about 3 times the footprint of the ones that you stayed in last night. It's got 3 bedrooms, and it's going to be fully serviced with a central heating system, a central cooling system, and shared elements like you would in a normal apartment building, but they're going to be each individual standalone bungalows. We are in the community of Proctor Point. It's one of the most beautiful places in the world, obviously. So what we did when we cut these trees down, we hired a local mill to bring his sawmill here. And so we built a little tool shed down below there. We 3D printed it, of course, and that's where he milled the lumber. So if you want, we can go down and check out the 3D print that we did there for this. So here we are at the Sakura shed. This is basically just a temporary building that we slammed up for us to be able to process the land, and we'll actually use this for storing material and tools while we're doing the build project. What's cool about this is probably the biggest single print we did with the Tillicum outdoors at that time. We've since done bigger stuff in Dubai. But we also experimented with something that we hadn't done before, and that was embedding fiberglass in the bead as we were printing. So if you look in a couple spots where the fiberglass was cut just a little bit too long, you can see that there was actually basically a fiberglass rebar left in the actual print. It's incredible because that little bit of fiberglass cut the cracking down to nothing. You know, in this material, we love working with this material, but it's very notorious for cracking. It's one of the things about 3D printing that we've all come to accept, that the added accelerators in printed mortar has a shrinkage that makes pretty much every print crack, and just that little bit of addition of fiberglass has made this thing hold up.
Where was Tillicum during this print, and was it stationary throughout the print?
So this was a single position, so the Tillicum only stayed in one spot. We didn't get the print done in one day like we'd hoped to, because we had a generator fail on us. We got the robot wet, somebody splashed it, and so we had to change some electronics on it. But the end of the day, it was like a single print setup, probably a total of about maybe 9 hours of printing.
If we get closer to the layers, can you describe some of the different things that were happening through the print?
Yeah, okay, so you can see in some situations where you get like a cleaner bead, and then you got beads where you can see much more of the pulsing that's coming from the rotor stator. This really has to do mostly with your water content and then what the accelerator mix is. We work with some excellent materials providers, but they sometimes have problems with consistency in their batch mixes. And so, you know, if you see this go to this, there's a very chance that we did a bag change there.
What about up top where it goes from a little bit like beady then to perfect? Is that a new rotor stator or is that a new day of printing?
No, that's probably a new bag, and then the humidity conditions changed in the mix itself that allowed for us to get cleaner beads.
How many days of printing did you do?
Well, the whole thing was done in 3 days, but if we didn't have stops, we probably would have done it all in 1 day. The rebar was actually quite hard to manipulate in some places because the printer was basically parked on a diagonal here. So if you look, this is where one of the feet of the printer would have been. The other foot would have been sort of in the middle there, and then the other 2 feet would have been over there. And so to get these long 20-foot rebar into the place, we actually had to weave it through the robot as we're printing. So it was a little bit hectic. And then, of course, we wanted to print in place electrical outlets. We had a couple of clogs. You can see we had a massive clog there. That was not very cool to deal with. And then we had a really funny situation. So because of this height, we had to do a nozzle change. So with the Tillicum, we can reach really far. But at some point, the length of the nozzle starts to become an obstruction when you get high. So then you have to shorten your nozzle and go to something else. And there is this function on ABB where you can push repeat cycle. And we printed these beautiful walls. And then the printer stopped printing. It went back to the bucket position. And it was just about to, we were just about to start cleaning up. And the printer started printing the first line again. So it plunged back down to the bottom. And the whole robot slammed into the wall. We thought the whole thing was just going to totally collapse, but it held up quite nicely. We were quite surprised. So
you have these indents where it folds into itself. Are those different printed elements, or is it all one layer?
Oh, this was all done in one shot. Each layer at the whole time.
So those are expansion joints?
It's a combination of an expansion joint, and it's also the dams for where the columns are going to go. So in this case, we also, I think we printed the first 3D printed truss in the world that's going to go across this. I can take you down and show you that. But basically you're going to have a 20-foot span here that's going to be unsupported. So it's pretty exciting. Yeah. So yeah, we have to obviously have massive columns to be able to support that mass of that truss. That we got from the hillside there. We're going to have quite a bit more to clean up with. Pull the rest of the logs down from the site. It's a mix of fir and cedar.
We have one of the biggest wall in progress right now. As I'll show you inside, each panel, after we print it, we mark it on the back just with a Sharpie. They're all coordinated with numbers. 1, 2, I think this wall goes to 121, I think. Something like that. Or that's the other wall. But the process comes down to just, we string out those ledgers, which are this treated plywood, and then the engineers proved 3 screws for each panel. It's pretty simple. Ledgers go up, we hang each panel in order, 3 screws go in, move on to the next. And it's all shingled, so once one goes up, the next one goes up, we can't take that down after that next row. So at the top, there'll be the soffit that goes up, and then we're going to try and do something cool on the sides where we put up, we're going to cut the notches in a tree as for the trimming, so we kind of go along with the idea of the trees that are coming out in the pattern as you'll see on the front too.
Are you guys happy on the flat print days? Or
actually, those are much nicer because they're lighter to lift and handle. It's actually very surprising how much weight and volume is added when there's a lot of pattern on it, like if anything double. Like I'd say the empty ones are 50 to 60 pounds and the full pattern ones are up to 120. I haven't weighed them yet, but it's what they feel like at least when you're hanging them.
120 is serious for 3 screws.
We're using some very
screws.
Seriously engineered screws for this. Don't worry, everything's been looked over and calculated. Right now, we have to print today. We accidentally, in handling, broke a couple through some serious abuse. Accidental, of course. So I know I have a list over on the whiteboard there. We need to do this guy, 42. That's just numbered, arbitrary number. They've been selected for each one. Then I'll go in, and we've already exported all the rapid code out, and then we have it all saved. I'll just grab, okay, I like to do 42. I'll open up my robot studio, which I don't have open yet. And that is how we communicate from our computer and our Rhino to the ABB robot panel. Load it onto a little pendant over there, and it's as simple as just clicking it and getting it going on the printer. Always dry run, make sure it's running good. There can be issues that happen between the CAD, Robot Studio, and the actual robot controller itself. So you're always dry running, make sure it's running good. Other big prints, you know, there's a lot more steps involved with proofing it and even more dry running, making sure everything is running smoothly. For this, it's like we've done 150 of them so far. So
this is a structural element that's basically a printed truss. We think it's the first one in the world ever done. It's going to sit on the Sakura shed there, so that's that 20-foot span that we were talking about. Where those wood blocks are is actually where it's going to sit on the building, and basically the majority of the loading it's going to take is itself, because it's obviously very heavy as a concrete product. The outer layer you see there is printed with Latacrete. The inner layer is a Lafarge material called ductile that we still use the printer to fill it with, but it has a much better self-leveling element to it. Because this was going to be facing backwards and not exposed, we had a tarp on the ground and we didn't really worry about getting the wrinkles out too much, which now you can kind of see the wrinkles in the print, but it's kind of irrelevant. The face of it's much nicer.
It looks very natural.
Yeah.
The wrinkles.
And then the other thing we did here that's also very cool is we knew where the rafter locations are going to be, so we actually 3D printed the knockouts for where the rafters are. And you can see that, again, we also use that same process of using rebar in the print itself, actual in the printed bead. But in this case, it's going to be cut where the rafters are. We only put them in to control the shrinkage while the two different types of printing material were curing.
Very nice. So how many more of these do you need?
Oh, it's just going to be one. It's going to be a sloped roof, so it's going to go to a ledge on the back.
So the rafters are angled. Can we take a closer look?
Yeah, of course. Yep. So each one of these rafters is basically the shape of a 2x4. You know, there's a little bit of thin material we're going to have to knock out. We're going to have to clean the edges, but the idea is that you'll have in this case, a 2x8 that travels all the way to the back. You know what? You can probably see this one's probably a little bit more accurate. So we'll get in there with a diamond cutter and we'll get the final surface the way the rafter will rest in it. But what's really cool about this from an assembly perspective, now you don't have guys up on the roof of a building or on a high location trying to measure out their 16-inch centers. They're already there. They're in the print. So this is an area where the BIM can translate to keeping the workload lighter for the contractors who have to interact with any kind of 3D printed elements.
If you were to try to estimate what's your cost to move this from here to over there?
That's a really good question. It used to be that it was about 50 cents a pound to transport things. I think that's gone up in some cases. We're very fortunate because we have our own crane truck, so we can move this ourselves. But the idea is that the elements could considerably be shipped in sections to the print site, and then they can do the heavy elements, the infill themselves.
I'm standing here at their loading dock where they receive all of their materials and equipment. Do you notice anything unique?
So what the guys did is they wanted to create something that was parametrically designed, and they had this idea of taking like a regular piece of concrete and then squishing it down as if it was like paper. So that's kind of why you see the wrinkles in there. And then each individual element was printed hollow, and then any kind of waste material we had, we filled it up, and then it became the block that ended up making a retaining wall that separates the loading dock from the driveway.
I bet it'll last a lot longer than the railroad ties.
Yeah, it should. I mean, the railroad ties, the trucks keep running into it, so that's kind of a good thing to have soft and flexible there. But eventually we'll probably replace that whole wall with 3D printed elements and maybe some embedded rubber. So this is the water line adjacent pump house. It's a rapidly deployed building, so it's self-standing structure. There's no reinforcement in it. It's actually sitting on the slab, and then we use post-tensioning so that we can actually hold the roof to the ground.
Can we go over and show, we'll get closer and show how that's connected, and then it joins in there?
Yeah, sure. So basically each individual wall was printed on its own. We transported here, and then we have a ball and cup strategy. And basically it's an interlock element that slides inside the other one. So we didn't have to actually grout this to the ground or anchor it here if we didn't want to. It would have stayed a couple of years, and then we could have just lifted it and moved it somewhere else if we needed to. Because we're going to be housing a pump in here for the water treatment facility, it stays permanently, so that's why we grouted it in. If you look on the back here, you can see there's an O. That's an homage to the Cirque du Soleil show called O, which is French for water. So we kind of like that, considering it's a pump house for water.
Beautiful.
If you you want, we can go inside and see how we did the inside.
It's a smaller layer height than the Fibonacci house.
Yeah, so this is a 10 mil is what we did for the layer height on this one. Oh, pooch, hang on there. Our hydro connection hasn't been made yet, so none of the control panels for hydro is here.
And this is totally modular, so you could.
Yeah, like those three walls are freestanding. Like they are independent of each other. If we wanted to move this, I mean, because we grouted it in, it'll be a bit more of a hassle, but the idea is these are rapidly deployed.
Very cool. And the green is so that it blends in with the background. It's a very green area.
The thing is, like, we're surrounded by multi-million-dollar homes here, and the goal of having a building that blends with the moss and the forest behind it, so that, you know, the people out there on that ferry, they probably can't even see this building's here, and that's kind of the main objective. You know, the natural beauty is what's most important to people here. You know, as attractive as our buildings are, it's okay to hide them too.
It's funny that this is the color to hide it, but it actually is matching the greenery of the back, especially if the sun's out. It's like bright green.
Yeah, I mean, obviously we just had a thaw. Like, there was snow cover here like 2 weeks ago. Everything was white, so. The idea behind this building is they could be configurable in different sizes and shapes, and they kind of interlock together, basically making whatever size building people wanted. This one here goes for about 20,000 USD. Shipping, of course, is extra. But they can go up to 3, 4, 5 meters wide by 5 meters long if you really wanted to.
Is that 20 number divided by 3 to get each unit?
No, that's this whole building. So each wall is probably like in about the 5,000 to 6,000 range, depending on the module you use. Custom graphics, of course, is different, but the base model is pretty quick for us to bang these out quickly.
And if somebody wants to run some rough calculations, what would the weight be to ship?
We kept these in under 2.5 tons per wall. That's basically our crane capacity, so that's where we keep things ourselves. Ideally, people who could lift 5 tons, we'll print them 5-ton sections, right?
And you can ship it before pouring columns in potentially if they want some kind of vertical load system.
Yeah, well, in this case, the columns are filled by the interlock element, but we can do other interlock styles if somebody wanted to do that, but it's unnecessary. You know, this is a very large amount of material for the size of the building. I think once you started going larger, you have some racking issues to concern yourself with, then maybe you'd want to do some different types of post-tensioning or columns. But in this case, this is a very robust structure. It's not going anywhere. So
if somebody said, I want to print a house, this would kind of be your go-to tried and tested strategy at the moment for design?
No, this actually would not be the cheapest way to print a house. We actually end up using more material than you would in a conventional house because of the interlock elements and the rapidly deployed nature of it. What's nice about this is you do not need to transport any equipment to site. You can just ship walls, and then the walls can go together. It's very fast. The assembly is minutes. Here, Jarrett, we're talking about kokanee salmon. They live in this lake. We're actually going to be building a spawning channel for them on this creek. We're working in conjunction with the University of Saxion and Enschede, where Twente's headquarters are, to put in a bunch of fish ladders. We're going to do some tests here on a closed system, so if you want I can show you the first prints of the fish ladders that we've done, and we can try to imagine them being in here.
All right.
We just had our frost. You can still see there's a bit of snow on the ground. We're really eager to get this project started with the University of Saxion because they want to qualify the way these fish ladders work. And so because we've got like a closed spring here, the water seeps into the ground and the water comes out of the spring. We can actually do some testing with the fish ladders here without being a danger to the environment. And so these 3 reservoirs that you see here are actually being held up by 3D printed fish ladders. But of course, you know, the height differential needs to be adjusted. What's cool is Iman and Ivo from Saxion, they used algorithmic design to build these things based on the water flow rate, the height differential, and they even took into consideration the species of fish that will actually be using them. Of course, we have not installed them properly yet because we're only on day 3, but eventually they will represent basically a travel path for the spawning salmon. So what's kind of cool about this is if Saxion had to do this in the Netherlands, they'd be locked up in applications with their environment minister for months, maybe even years, whereas because we're on a closed loop water system here, we can test the ladders out quickly. It's kind of cool, you can see the three ladders from here, different elevation changes. Yeah, so for those of us who grew up in the Kootenays, we've been watching the decline of the kokanee salmon for a really long time. And it's kind of on all of us now to do some sort of effort to try to rebuild the habitats that have been lost. We've obviously got a lot of groundwater on this lot, and so I actually just dug a new culvert there to move some of the groundwater to fall off onto the pond here, and it'll actually help oxygenate the lake for the fish. We printed ourselves a little half pipe on the Leonardo. The idea is that we'll place the 2 quarter pipes and then we'll put a slab in between them. And this is for us to hang out and skate during lunch break. The retaining walls that you see back there were printed with the Tillicum. That's basically going to be sort of a planted garden area there. We'll put some tables and people can watch the kids skate. And we'll put the half pipe right on the steep hill there so that when the kids bail, including us, we tumble all the way down into the field that's below. But we got to wait for the ground to dry up before we can place it. You can see the truck was sinking in the ground.
Last time I was here, the stairs weren't quite installed.
No, and actually there's a different set of stairs here than we were there. These ones were actually designed for the actual hillside dimensions, whereas the prototype stairs are actually sitting over on the cul-de-sac now. Got a couple of other prototype prints down there. So there's like the top of a dome that's going to be like a weird grass thing, and then a bench that was actually for the fish for the park that you saw when you were here last time. We did 2 tests here. We did one with 1K and the other half for 2K. The idea is to try to print different rates and build heights. But the real concept behind this patent is that it's a structurally insulated panel, which means that there's an inside layer and an outside layer, and the 2 outside layers are concrete, and then the inside is insulation, and they don't touch each other. But when you look at the process we did, we actually start with a mold, and we printed the mold, then we put an expansion foam on, and we mill the foam, and then we print against the foam surface. And what this allows you to do is have almost a zero energy loss. The concept is to get the net zero ready with this. So the patent really is in the use of 3D printers for getting these compound curves to make these structurally insulated panels. So the load is being borne by the concrete, and then the styrofoam is the insulation.
Usually in a printed building, the layers move in 2 axes, like the X and the Y axis. But here, it moves in all 3 axes for each layer, so you have a non-planar structure creating the curvature you see behind me.
Last time we just did the column, but we hadn't done the bench yet, and then we printed the bench. So this is an old mine shaft that we have on the land here. What's kind of cool about it, I don't know when we're going to get to it, but we're going to actually use the Tillicum or a small robotic printer to actually shore up the mine shaft as an example of how this can be used for all sorts of mining operations all over the world. They've got real safety issues with cave-ins or using very expensive.
How would the freeform nature of the printer be useful for this application?
Well, what's really cool about using 3D printing for this, you'd be using something that would be like an accelerated mix, similar to like a shotcrete, so that would actually have like a high buildability in difficult surfaces to get at. But you can have the printer be laser scanning as it's printing, so nobody has to go in there and draw this. They can actually just have the printer measure a distance from the wall that it needs to be at or the roof it needs to be at, and then apply the mortar or the shotcrete.
Lasers?
Lasers, it could be proximity sensors. There's multiple ways of dealing with it, but yeah.
LiDAR?
Well, obviously LiDAR is the easiest to control, so that's probably going to be the most likely strategy we use. But
have you been in there?
yeah, we can go in. I mean, it's been collapsed.
Yeah.
So, like, if you go up the hill there, it's all caved in.
How far in can you go?
Well, 15 feet maybe. You can go in if you want.
Not that. You think this is also local timber?
Oh yeah, definitely. But most of the trees that could support logs of that dimension have all been cut down. There's not a whole lot of big trees like that left, or if they are, they're far away. You can really get an idea of like how complicated the surfaces are of a mine shaft. So any kind of manual measuring of these things would be virtually impossible.
Was this a natural cavern that they then built out?
No. This was created by humans.
Dynamite?
Definitely, yeah, dynamite and hand picks.
What would they have been looking for?
This mine was actually used, what I've heard, it was for blue lithium, which is part of the fluxing process in smelting of lead and zinc. We sort of lovingly call it Santorloki Heights or something of that nature, because it's going to be based on the architectural style in Santorini. But we're going to have somewhere between 20 and 40 houses here. It's going to be a shared wall compound, but each individual bungalow will have its own entranceway and exitway, and the whole thing will be 3D printed. Each building will be unique. The whole thing will be parametrically designed and built in a BIM that will allow us to have shared infrastructure such as parking and heating systems and whatnot. And then what's really cool about it, I'm not sure if you've seen footage or videos of that part of the world, you could have multi-million-dollar homes right next to like $100,000 homes, and you can't really see where one ends and one begins, so you don't have this sort of weird separation of classes because of economics, because the community is really designed to be inclusive for people of all economic backgrounds.
We've printed a bunch of wall panels which we are mounting today. We're trimming them to size, drilling holes so they can be mounted on this. This is sheathing, slaving.
Is it difficult
ledging.
cut printed concrete or like any other cut?
We reinforce it with glass fiber, and our big ass Milwaukee ceramic disc will make proper work out of it. So before we trimmed these are trimmed for go over the door or to work up to the door. But, they were all cut to size on the table, saw for the ceramics. Made a mold for it, so they're all square, nice and square.
You guys have so much going on here. How could you grow faster?
Yeah, Jared, I mean, we're doing as much as we can, but working in small town BC, it's a little hard to get access to the funding and the supplies and equipment and support we need. We're a very motivated group of people, and we just need, a little bit of that back support to get us there. We want custom and we want fast. Help us get it done. Yeah, give us a shout at twente-am.com. Talk to Ian. He'll tell you what you need.
You want to come down? Did you come down a bit?
We're just trying to get it level here before we place it, grout it, weld it, release it.
Things become permanent fast.
They do. Once you make that choice, it's over.
So what's the joining method?
We're welding across these pieces of angle iron here that are attached to our rebar cage. It's going to hold the piece in place after.
Did you have to bend your rebar?
We did, yeah. We formed it to match the inside. Well, it was the inside, but it's actually the outside on the assembly.
The inside of the outside.
The inner side of the outside.
But on the other side too.
Yep. Yeah, it's all reinforced just inside the outer shell. You can see over here we've got it welded across to keep it in tension, and then we've mortared the rest of the joint. And it wants to fall in, but the mortar's holding it in compression. The steel's holding it in tension. Once we get this last panel in here, it should be quite a secure little sphere. We're here at my lot, and this is going to be where my family and I spend some years here together. So this is doesn't look like much, but I can sure see it.
It's pretty well leveled out already.
It is, yeah. So had to do that to help figure out what my elevations will be, the approaches. There's going to be a septic tank in here, so there's a lot of visualization going on right now. I've got some good drawings started, some floor plans. My parents, my wife's parents, we're considering how we're gonna accommodate everybody, and we've got 2 kids as well. Yeah, this is the entrance here. We've even started a little bit of a garden here. We've got some stuff down here. We've got a little strawberry patch right behind you. We got some more strawberries this year. Looks like they're multiplying quite well right now.
So where will the 4 corners of the house be, or is it even 4 corners?
Well, it is 4 rounded corners, if you can imagine. We're going to take advantage of 3D concrete printing to the fullest here. So over here is the main house layout, and then we're even talking 11, 12 foot tall ceilings in the first floor, so that we can get up to a nice elevation for the second floor. So half of the first floor, the ceiling will be half the second floor and half deck for the second floor.
Cool.
So we'll have the second floor set back into the bank there.
That
will
bank
be
you purposely leveled for the deck, or
well, no, we kind of dug into that corner there just to see what was in there, and there was a lot of bedrock, so we kind of abandoned going in there any further. We just kind of scraped it a little bit and checked it out. We did have to bring the rock hammer up here to really hammer out some of these parts.
are there any unique or one-off features you designed into your printed home?
Well, yes. We're going to have a retaining wall on 3 sides, and it's going to be quite tall, so we're going to print that.
With any kind of design?
I want a rounded corner over there, so in the back there we're going to have 2 bedrooms. Master bedroom on this corner, a diagonal kind of a wall, so it won't be a square box, it'll be like a kind of a chamfered sort of
then you want to put the in-laws
box
over there on the other corner.
Well, they'll probably take the first floor, so we'll take the second floor. But to start with, we'll do the first floor. This retaining wall will have some cool features printed into it. We'll have a stairwell of some sort, and I'd like to curve it. We might even try coming in from 2 sides, but that'll take up a lot of floor space, so we're still talking about what we'll do there. We'll have a center wall down the middle with holes in it for entranceways and walkways, and that'll be part of the structure for the second floor.
Cool.
So that'll pick up the roof. So we'll definitely be incorporating that in the first floor.
Do you have a plan for the roof yet?
No, but it's going to be something pretty flat. Either very flat to the point we can put a deck on it, or like a 212 kind of slope, real gentle slope. Yeah, so we'll have a bit of a covered area outside the first floor. That wall over there will have a covered area as well, with a set of stairs on the back side going up to the second floor. Here we are at that little bench that we excavated for exploring to see what's down here. But one thing we found is just down in here, we found some black rock mixed in with the brown stuff, and the excavator, he's a friend of mine, he suggests we leave a little opening in our basement to get at it for the gold mine later on.
Is black rock a signifier of gold?
It can be, it sure can be, and that's what he was telling me, that's the sort of rock you want. Of course, he says you don't need a little finger of it, you want the tip of a volcano sort of amount. And then we were doing a little bit of fun work up here with the family, making a bit of a bench we could throw a tent up. Super safe for the kids, right? So we're gonna sheet it before we do anything serious up here. But this is the second floor view, and this is why we want 12-foot floors in the basement. Keep it accessible without stairs for the in-laws.
Recovery, I gotta say.
Not bad. Thanks. I actually kind of knew it was bad. I was half expecting it.
Man, this is a beautiful spot you got.
It's a gorgeous view here, eh? And there's Ian's carved out several other lots that extend out towards the water that way. He's got them napkin sketched out right now, so
looking for some neighbors. Yeah, if anybody has any suggestions about what I should be doing with the lot here, I'm really keen to hear everybody's ideas. You can reach out to me at jimz@twente-am.com. Love to hear your comments or ideas. Yeah. And what else?
That was pretty good.
That was it? Okay.
All right. That's the video. Catch you guys on the next one.
Thanks for coming.